What does it really mean for an AI to think? Today, we're diving deep into Interview Angular, TypeScript fundamentals. Angular interviews focus on TypeScript as a core skill, not just as a decorative feature in code. They assess whether your code can clearly describe the product before users interact with it. TypeScript adds typed syntax to JavaScript for better tooling when working at scale. Angular is built directly on this foundation. Weak types can hide defects in code. Strong types help catch failures earlier. But here's where it gets interesting. Runtime is too late. JavaScript lets almost anything pass until runtime. Next, Angular cannot protect a codebase if every model is importantly, every response is trusted and every form value is guessed. Thus, the bottleneck is confidence. More specifically, when types are vague, reviews slow down notably, refactors become dangerous, and migrations stall. The app becomes fragile as a result. So what's the real problem? Let's talk about the invisible bug surface. The root cause is invisible uncertainty. Null, undefined optional fields, and dynamic JSON can seem harmless. They become problematic when real user paths touch them. TypeScript's strict null checks treats nullish values as separate possibilities. This forces developers to handle them intentionally. TypeScript helps catch these issues early. This raises a critical question. Contracts before components. The first breakthrough is choosing the right contract. An interface names an extendable object shape A. Type can also describe shapes, but it can represent unions, tuples, primitives, and combinations. In Angular, this choice decides whether models stay readable, reusable, and honest. In TypeScript, importantly, this decision affects code maintainability, thus using interfaces is often preferred for clarity. More specifically, interfaces provide a clear structure. Notably, types offer more flexibility in complex scenarios. Now let's zoom in on classes. Create boundaries. Classes turn contracts into behavior. Next, Angular components and services are TypeScript classes. Importantly, public, private, and protected define where state may move. Lite protects values that should not mutate. More specifically, generics preserve the exact model flowing through services. Thus, they avoid returning a convenient lie. Here's something most people overlook. Uncertainty becomes explicit. Union types make product states visible. Next, a request can be loading, success, or error. Importantly, a role can be admin or user. Thus, a route param can exist or be missing. Optional chaining gives safe access through nullable data. More specifically, it should clarify risk, not hide weak modeling. Think about this for a second. Stop string drift. Enums and literal unions solve string drift. Next, status names, roles, feature flags, and API modes should not be random strings. Importantly, use enums when you need a runtime object. More specifically, use literal unions when compile time precision is enough. Thus, TypeScript becomes a domain language, and this is where things get complex. Decorators become architecture. Decorators connect TypeScript to Angular's runtime model. Next, @component metadata tells Angular how to render and instantiate a class. Importantly, metadata also defines how a component is imported. Thus, the AOT compiler extracts metadata at build time. More specifically, it generates factories for execution infrastructure. Notably, this process turns TypeScript structure into runnable code. But here's where it gets interesting. Strict mode is the filter. Strict mode is the interview filter. Strict, no complicity, and strict null checks harden TypeScript. Strictemic pushes that discipline into HTML. The Angular template checker can verify bindings. It infers directive generics and respects nullability. It also types event effectively. Angular ensures type safety in templates. So what's the real problem? Let's talk about forms reveal the truth. Type forms expose weak Angular, immediately reactive forms are strictly typed by default conformal. Warm and form array describe the real form model. Invalid property access fails at compile time. Autocompletelet improves with better developer experience. Dynamic enterprise forms stop feeling like guesswork. Angular provides powerful form handling capabilities. This raises a critical question. APIs need trust boundaries. APIs need trust boundaries to ensure secure communication. Help.get getConfig tells TypeScript what shape you expect, yet Angular documents that the generic is a type assertion. Notably, this does not verify runtime data integrity. Strong candidates add DTOs, unknown types, and mapping functions. Importantly, validation is essential for reliable data handling. Thus, designing trust boundaries is critical for API security. Now let's zoom in on make bugs visible early. Angular developers who make invalid states unrepresentable will shape the future. TypeScript fundamentals are not just type versus interface details. They are the operating system for safe components and reliable APIs. Bugs that appear before the app runs change the interview process. Importantly, early visibility of bugs leads to better debugging. Thus, focusing on type safety improves overall application quality. More specifically, typed forms and scalable refactors depend on this approach.